I have problem number 38 from chapter 7. My problem asks me to describe the change in hybridization of the aluminum atom when aluminum trichloride, AlCl3, interacts with a chloride ion to form AlCl4-. The first step I took in determining the change in hybridization of the aluminum atom was to draw the Lewis structures of both AlCl3 and AlCl4-. Cl is in group number 7, therefore it has 7 valence electrons, and aluminum is in group 3, therefore it has 3 valence electrons. The same goes for AlCl4-. In AlCl3, there is a total of 24 valence electrons. Once you subtract the number of electrons for each bond, there is 18 electrons left. I distributed the 18 electrons to each chlorine atom, and there were no more electrons left. In AlCl4-, there are a total of 32 valence electrons. Once I subtracted the number of electrons in each bond, I had 24 valence electrons. I distributed the electrons to each chlorine atom. Looking at the structure, AlCl3 has a trigonal planar geometry, whereas AlCl4- has a tetrahedral geometry. To determine the change in hybridization of the aluminum atom, we can look at the geometries to determine this. Since AlCl3 has a trigonal planar geometry, it has an sp2 hybridization. However, since AlCl4- has a tetrahedral geometry, it implies an sp3 hybridization. Therefore, there is a change in hybridization of the aluminum atom when AlCl3 interacts with a chloride ion to form AlCl4-.